Now, in this exercise, all my logarithms are multiplied by a number outside, meaning that the first property that I have to apply is the power property. So the first thing I have to do is to plug in those values as powers of the arguments. Now I'm going to simplify this. Logarithm base 27 of 9 to the power of 1/2 is 3, plus logarithm to the 729 to the power of 1/3 is 9. Why? Because 9 to the power of 3 is 729. So this is logarithm base 27 of 9 minus logarithm base 27 of 9. So from here, there are two ways to do it. Just by thinking if you want to continue with properties of logarithms or just to continue using your knowledge in algebra. So I'm gonna do the two of them. So by just continuing to applying properties of logarithms, I'm going to simplify the addition of these two logarithms by applying the product property, meaning that logarithm base 27 of 3 times 9 being 27 minus logarithm base 27 of 9. From here we have a quotient, so this is logarithm base 27 of 27 over 9, and this is logarithm base 27 of 27 over 9, this is 3. And lastly, we can simplify this, and this can be simplified because you know that 27 and 3 have a relationship. You know that the cubic root of 27 is 3, or in other ways, 27 to the power of 1/3 is 3, meaning that the logarithm base 27 of 3 is 1/3. I'm going to prove you that you can find the same result using different techniques, but as long as you use the properties of algebra and exponents and logarithms carefully, there's nothing wrong with it. So from here, we can first realize that my second term and the last term are exactly the same terms. So we can cancel them because we have plus something minus the exact same thing. So from here we can go into just logarithm base 27 of 3. And as we have stated previously, we know that 1/3 is the power to which we have to raise 27 to obtain 3. So this is the final answer. Two different ways, same goal. So here we have to realize that we have a bunch of logarithms and a number multiplying them. So the first property we have to apply is the power property. This means that this number that is multiplying my logarithm can be plugged as an exponent for the argument. Again, the number that is multiplying my logarithm can be plugged as an exponent of the argument. From there, I'm just going to simplify the resulting expression. This is logarithm base 31 of 9 plus logarithm base 31 of 16 minus logarithm base 31 of 144. From there, I'm going to apply the quotient rule here because I have two logarithms subtracting each other. So by applying the quotient rule, I know that this can be simplified as logarithm base 31 of 16 over 144. Now I have two logarithms multiplying each other, adding each other, so this can be simplified as logarithm base 31 of 9 times 16 over 144. And from here, you have to know that 9 times 16 is 144. Thus, 100 over 44 over the same number is 1. And what power can make any number into 1? The answer is 0. Any number to the power of 0 is 1, meaning that this is the end of this simplification. Let's look at some harder examples, like So let's look at these examples. The first one is telling me logarithm base 5 of square root of 5. First things first is that you have to remember the properties of exponents. You know that any radical function can be rewritten as a fractional exponent. So first thing you have to do is always rewrite it as a fractional exponent. You know that square root of 5 can be rewritten as 5 to the power of 1/2. From here, there are two ways to think about this. The first way to think about is applying properties of logarithms. That is, you know that if you have a number that is being used as an exponent inside your logarithm, you can plug it outside of your logarithm multiplying. That means these properties go both ways. That is, you can use it to transform this into this or this one into this one. These are equivalences, so you can use them in any order or way as you like. So I'm going to plug this 1/2 outside using the quotient property, because any exponent can be plugged outside as a number multiplying the logarithm. So 1/2 times logarithm base 5 of 5 to the power of 1/2. Oh, sorry, just 5. From here, we can simplify this logarithm because you know the value of that logarithm. Logarithm base 5 of 5 is 1, because 5 to the power of 1 gives you 5. So this can be simplified as 1/2 times 1. That is, you can transform this logarithm into its numerical value. That is 1. So this is 1/2 times 1, 1. And that's it. I'm going to show you another way to solve this same exercise. So, starting from the beginning, you know that this can be rewritten as logarithm base 5 of 5 to the power of 1/2. So you can always answer this question. 5 to what power gives me 5 to the power of 1/2? And the answer is obviously 1/2. Different ways to get to the same result. Another example. I have two numbers multiplying here. So I can use the properties any way I like. I'm going to solve this exact same exercise two different ways. The first one is going to be by applying the property of powers. So I'm going to plug these radicals outside. So you know that this is logarithm base 2 of 8 to the power of 1/2 plus logarithm base 2 of 2 to the power of 1/2. By the quotient property, I know that this is 1/2 logarithm base 2 of 8 plus 1/2 logarithm base 2 of 2. From here, I already know I can find the values for these logarithms, because logarithm base 2 of 8 is 3. So this can be expressed as 1/2 times 3. Why? Because you know the value of this logarithm, so you can substitute it by its numerical value, that is 3. And the same goes with this logarithm. Logarithm base 2 of 2 is 1. So instead of writing logarithm, we can just write its numerical value. So this can be simplified as 3/2 plus 1/2. This is 4/2. So my final answer is 2. Another way to solve this exact same exercise is by using the property of the product property. So I'm going to multiply these two arguments. And by the properties of exponents of Mate 1, we know that we have the same exponent. We can simplify the product of these two roots as 8 times 2 inside the radical. And this can be rewritten as logarithm base 2 of square root of 16. And you know that the square root of 16 is 4. And you know that 2 to what power gives you 4? The answer is 2. So you can see that you can use these properties the way you like. As long as you know laws of exponents and laws of logarithms, you can find different ways to get to the same result. Let's do the last exercise. So in this exercise, I'm going to rewrite the square root as a power. So this is logarithm base 3 of 27 to the power of 3, and then that power is raised to the power of 1/2. Plus logarithm base 3 of 1/9. This second logarithm can be evaluated really quickly because you know that 3 to the power of -2 is 1/9. So this can be already simplified to -2. Why? Because remember, 3 to what power gives you 1/9? You can do this by steps, by first knowing that 3 to the power of 2 gives you 9, but because you want a fractionary or reciprocal result, your exponent has to be negative. So this logarithm can be switched by its numerical value. Now, in this other term, let's apply the power rule, meaning I'm going to remove the powers inside the argument and put them as numbers multiplying the logarithms. So this is 1/2 times logarithm base 3 of 27 to the power of 3. Notice that I still have a number as an exponent inside my argument, so this can be rewritten again as 3/2 logarithm base 3 of 27 minus 2. And you know the numerical value for this logarithm because logarithm base 3 of 27 is 3. So this can be rewritten as 3/2 times 3 minus 2. And this can be simplified as 9 over 2 minus 2. And this can be simplified as 5/2.